let's explore a bit further what's possible with Vellum in conjunction with DOPs. And I might have mentioned this, but the setup we're going to build here was my first exposure to using Vellum in DOPs. And it was within the side effects forum that someone pointed out this technique to me, so thanks so much for that. And in order to demonstrate that, I want to build kind of a string setup by dropping down a geonode, diving in there, dropping down a line. Let's scale this to be a length of 100, and for now, let's say have it contain 64 points, and we'll drop down a point jitter to move those points around a bit. And then maybe let's drop a resample, wire this in, and within the resample, I want to set the length to 0.05 and resample this as a subdivision curve. So we get something like this here, uniformly distributed points along this curvy long line here. Also, let's move this up a tiny bit and give it an initial velocity using a pointer angle and just give it a bit of a velocity along the y-axis, say minus 0.5, like this. Next, I'll drop down a Vellum constraint to configure this, and I want to configure this as a string. Let's just check thickness and set this to 0.02 maybe. Everything else set to default. Next, let's drop down the DOPNet. For this one, we can wire in our Vellum directly and then dive into the DOPNet. Again, drop down a gravity, then a merge in a static solver, and in that, we'll wire in a ground plane, sitting at 0. Next, our Vellum solver, which needs a Vellum object, which is already set up to our default inputs, like this. And let's just save this, and let's simulate this. And while this already looks convincing, and let's enable real-time here, and zoom in a bit, you can see this keeps jittering after it's being dropped, which annoys me, so let's fight that. So what I want to do here is I want to evaluate how fast is a point moving at a given point in the simulation. And if it's below a certain threshold, I just want to pin it so it sits there without moving. So let's wire in a merge into the last slot of our solver. That is the slot that gets executed or evaluated after the simulation in the Vellum solver ran. First thing I want to do is use a pop wrangle, and we previously mentioned that Vellum is just pops particles. And in here, I want to check if my velocity is below a certain threshold. So I want to check if the length of my velocity is below, say, 0.5 or 0.25. And if it is, I want to increment a float attribute, let's call it slow, and add 1 to it. Could make it an integer as well for now, but I'll use a float, so I can add fractions here as well. Next, I want to create a group that is a pop group. Let's call this one pin this, and we want to enable the expressions here, and if our attribute slow is bigger than, say, 10, so if it's been slow for more than 10 frames, we set its group to be pin this. And finally, let's drop down a pin constraint, and finally, let's drop down a Vellum constraint, set this one to pin, and for now let's just leave it at the default setting, which is permanent. However, we only want to pin points that are in the group pin this. So let's keep our fingers crossed, save this, and hit play. That is not yet working as expected, so let's check what went wrong here. And yes, of course, my Vellum constraints have to be set up to create the constraints each frame and not only once. Let's try again. So we can see now, except for those few jittery points here, this freezes my simulation after a few frames, at which the particles are kind of slow. So let's stop this and tweak our settings a bit. Maybe increase the length, which is regarded as slow, so it catches those jittery particles as well. Yeah, and we now have a totally pinned simulation at the end. So what we see here are, on the one hand, a technique to slow down these particles, using a pop wrangle to evaluate the velocity of the particles, setting an attribute depending on the velocity, and then evaluating that attribute in a pop group, which then gets fed into a vellum constraint set to this group. On the other hand, I want to point out the function of this merge here. So what we could have done instead is just wire those together linearly here, those three nodes. However, in order to keep your tree more readable, and even if your tree gets bigger and bigger and gets more branches, I really like to stick to those merges, to group together certain nodes and make sure they are being executed in the right order. So again, we are executing from top to bottom, left to right. So this, and this. Also, let me stress that the usefulness of this technique is not limited to simulating a string or a hair, but keeping any type of vellum simulation from jittering after a while. Your main parameters here are, of course, on the one hand, the speed, which you regard as slow, the threshold, and on the other hand, the number of frames where this threshold had been crossed before we pin the animation of a given particle. So, that's a quick one, but a very essential one. I hope you find it useful, and until next time, it's cheers and goodbye.